Hello everyone, this is Dr. B and we're going to do activity 4 in the Concord Consortium. Exercise called What are our choices for supplying energy for the future? First you want to go to learn.concord.org and you want to log in. Oops. I've already logged in here. So I would be logging out. You want to go to what are our choices for supplying energy for the future. You want to click Run by Myself. And then you'll see the High Adventure Science portion that you want. Right now, we're going to go to 4. That's activity 4, using the menu. So we use the menu on to activity 4, and now we're going to start on page 1 by clicking here. We're going to use an interactive computational model and real-world data to evaluate the environmental impact of extracting natural gas to generate electricity. We've used an interactive model in the last activity 3. We drilled for natural gas in shale formations, and we're going to continue evaluating how that impacts the environment here. So energy supplies and demands have changed greatly over the past 100 years. And thinking about using energy resources to generate electricity, planners have to think about several things: the location of the resource, the abundance of the resource, the usefulness of the resource in generating electricity, health and environmental effects of using the resource to generate electricity. For example, the location of the resource for Minnesota, wind turbines are about a 2-hour, 3-hour drive from here, the main site for wind turbines. So in order to get that power to St. Paul, where we are, they have to push it through high voltage lines, and they lose some of that electricity as it travels through the lines, just as a very long water pipe might lose some water on the journey. You lose a little bit of electricity due to resistance in the wires. It turns into heat, and it's used up. The electricity, like electrical energy, is transformed to heat energy. In activity 2, you learned a little bit about different fuels can be burned and how wind and water power can produce electricity. In activity 3, we learned how natural gas is extracted from shale. The picture over here shows drilling in the Bakken Shale in North Dakota, which we know is not too far from Minnesota. In the Bakken Shale, drillers are using rigs to drill horizontal wells, so they drill down vertically and then they drill sideways, that's the horizontal drilling, to extract oil and natural gas from deeply buried shale. So shale is that layer that's way far down that holds oil and natural gas from rotting biomass that was deposited millions of years ago. The question facing all energy resources is how the resource can be used to generate electricity for humans while minimizing disruption to natural ecosystems. It's important to carefully evaluate each resource, both for its usefulness as an electricity generating source and its effect on the environment. And this activity will look in depth at the process of extracting natural gas from shale as a case study to evaluate costs and benefits associated with an electricity generating source. In activity 4, you'll explore the costs and benefits of other electricity generating resources to make a resource-wide comparison. So let's hit the next button here. So there are some atmospheric effects. We've all heard about climate change. One cost that needs to be considered when evaluating energy resources is their effect on the atmosphere. Resources that are burned to generate heat, fossil fuels, biomass, municipal waste, aka garbage, release pollutants and carbon dioxide, a greenhouse gas, into the atmosphere. So greenhouse effect makes the earth warmer. And it's currently making the earth a little too warm, which is changing ecosystems and weather patterns and the climate. Natural gas, also called methane, is a colorless, odorless gas that's derived from the breakdown of organic material. It's the natural gas that heats your home. It's also composed of 1 carbon atom and 4 hydrogen atoms. Methane is the simplest hydrocarbon. It burns very cleanly. So it's nice in terms, it's better than coal because it doesn't produce as much air pollution. Burning natural gas releases carbon dioxide, which is a greenhouse gas, and fewer particulate pollutants into the atmosphere than burning coal or petroleum products. Greenhouse gases trap heat with Earth's atmosphere, leading to global warming. But methane, and this stuff, natural gas, is methane, is a powerful greenhouse gas on its own. In other words, if we let natural gas or methane escape into the atmosphere, it does a lot more damage than the same amount of CO2. 1 unit, 1 pound of methane is as powerful as causes as much damage to global warming as 21 pounds of CO2. So that's a really big deal. Letting methane out into the environment is a big deal. It's a potent greenhouse gas. Are there clear advantages for using natural gas over coal for electricity generation? Well, yeah, because it doesn't produce as much nasty smoke and air pollution. So I'll let you answer question 1 and 2. You can pause the video. How certain are you about your claim based on your explanation? Well, I know coal produces sulfuric acid, which comes down as acid rain. It also produces a number of particulates. Particulates are tiny little particles that we breathe in. Some of those particles, called PM 2.5, are so tiny that they go right into our bloodstream and can cause a lot of systemic health issues. So we want to avoid that particular matter we get by burning coal. We also get that particular matter by burning wood. So we're going to continue here looking at the future of natural gas and methane. Natural gas is methane. Some scientists are concerned that increased drilling for natural gas will release more methane, a potent greenhouse gas, into the atmosphere. The first graph shows the atmospheric methane level from 1980 to 2009. Let's look at that first graph here. So here's the atmospheric methane level. It went down for a while, and then it's starting to go up. The total atmospheric methane level is affected by emissions all over the world, not just in the United States. The process of horizontal drilling and hydraulic fracturing for natural gas began in Texas in the 1990s, so right around in here. The first drilling in the Marcellus Shale in Pennsylvania happened about right here. Let's look at this graph. This is U.S. methane emissions by source. So waste management went then down and then probably back up again as garbage burners started up. Probably not everything released from waste management is methane, but some of it is. Agriculture, that's cows, and the breakdown of animal waste. Energy production here. It looks like there's a little bump right here that looks like it might be related to using natural gas or drilling for natural gas. What will happen to the atmospheric methane level in the future as more natural gas wells are drilled? Well, it would make sense that some methane is released. It's not all going to be captured. In fact, some places in the Bakken Shale, they just burn off the natural gas. They don't even bother to capture it. There's not enough. So they just light it and let it burn all night. And the whole sky is lit up. I have a friend who has a family in North Dakota, and she just could look out, and the whole sky was lit up with people torching the natural gas from their oil wells. And they're burning it, so it's releasing CO2, but some of it's probably going out that isn't burned. How certain are you about your claim based on your explanation? Well, I found a New York Times article that talked about burning gas that's coming out of the Bakken shale. So I'm pretty certain about my rating, but you go do some research to be certain about yours. What can you find out about the Bakken shale and the methane coming out, the methane or natural gas coming out of the Bakken shale area in North Dakota? Another cost to consider is when evaluating energy sources is how the resource extraction affects the surface. How does the process of extracting shale gas affect the surface? The image shows what Marcellus shale drilling operation looks like on the surface. This is probably satellite data. There's some frac pumps, there's a data monitoring van, there's some water trucks that might be bringing in water to pump down the well, or pump down the pipe where they're trying to burst open the cracks after they explode things. I'm not sure what frac blenders are. Frac sand is also used to open up some of those cracks. Fluid storage tanks is probably for storing the water that's used for fracking so it doesn't go back into the water table, because sometimes it gets polluted with contaminants as it's pumped down into the natural gas. It picks up things from the cement casing, some lubricants, and it's not safe to drink anymore, so they need to kind of contain it. According to the data from the Pennsylvania Department of Environmental Protection, as of June 30th, 2012, there were 6,391 active natural gas wells in the Marcellus shale. There are probably more now because drilling for natural gas has exploded in the last decade or so. This doesn't mean there are 6,391 drilling pads, however. Multiple horizontal wells can be drilled from a single drilling pad. So you can see these are the wellheads, so it looks like there's several wellheads here on this drilling pad in Pennsylvania. As of June 2012, drilling for shale gas in the Marcellus shale has affected approximately 21,000 acres. That'd be about my neighborhood. About 0.7% of the total land in Pennsylvania. What might be some consequences for local habitats for drilling for shale gas? Well, looking at this big concrete pad, no plants can live there, no animals can live there, and they probably, with all this traffic going in and out, you've got water trucks, you've got data monitoring vans, you've got all the people who work here going back and forth, it's probably going to disturb some of the wildlife that live around the site as well. So plants and animals can't live there. Plants and animals are disturbed by trucks coming back and forth. On the other hand, what is a long-term consequence to the environment if drilling for shale gas is limited to protect local habitats? Well, limiting natural gas, burning it, would limit the amount of carbon dioxide released, which would certainly help everyone, every local habitat. But the long-term consequences of not having natural gas might mean a lot of people are cold. So it would slow down climate change, or we might have to burn coal, and then we might have to go back to that nasty air pollution from coal, or it might encourage us to use more renewables. Here in Minnesota, the building that you live in is likely heated by natural gas, and so if we don't have natural gas, we're going to have to find some other way to heat our homes. We might have to go with geothermal, which is a little bit complicated and runs on a lot of electricity, but it's easy to get electricity from renewables. It's harder to get heat. Or we might have to burn coal to heat our homes with electric heat. We might have to burn wood, which leads to deforestation. There are a lot of possible long-term consequences. Some of them are good, and some of them are not so good from not drilling natural gas. It's not an easy answer. Another cost to consider when evaluating energy resources are the effects you can't see. How does the extraction of resources affect the land under the ground? And this can affect a lot of people who don't necessarily live next to the drilling pad. They can drill underground for a long ways. And so the earthquakes that the explosions cause and the water pollution that can happen when you're using water to as a fracking fluid, that can disrupt the lives of a lot of people in communities around the drilling sites. Another cost to consider when evaluating, what you don't see on the surface can affect the surface. There can be problems during drilling and production of natural gas, just as there are problems with extraction of any kind of energy, whether it's solar or wind or coal or biomass, that can affect the surface. What can go wrong? Wells can have casing failures, which is the seal between the pipe and the aquifer, and it can develop a leak. So you leak contaminated water into the aquifer where we get our drinking water. Waste fluid that is returned to the surface can be spilled and leaking into the aquifer. Using the model to drill some wells and monitor the contaminant graph for pollution. So we're going to look at this graph. We're going to drill some wells like we did in activity 3, and so let's drill some wells here. We're going to go down below here. We're going to get a drilling site here. Go up to the top, start a well. Don't go down at too fast of a rate here, because we don't want to overrun the shale. We're looking for a layer with red dots. So there's our layer with red dots. You can just barely see them there. Now we're going to drill right, but not too far right, because we want to give ourselves enough room to put another well down under this one. So we'll set off some explosions. We'll fill it with water, so that can potentially leak and contaminate the aquifer here. We'll pump out the fracking fluid, and hopefully we'll see that we get some natural gas production here. Yep, we get some natural gas, and we also get some contaminants. Let's drill another well and see what happens, and see if we get more contaminants. This one, let's use the fracking fluid propane and see if there's any differences here. I'm going to go down into the shale layer, and I'm just going to go up. I went too deep this time. I was going to try to go, and I can't go back up. And I can't drill sideways from where I want to go. Let's see if we can get any. We're not going to get much. We're not going to get much methane out of this one. Probably not going to get any. We'll get fired. Well, let's see if we can put a third well. See if we can be tricky here. The third well down next to this one. Hopefully we won't overrun the last one. We can go sideways now. We're going to overlap a little bit. Fill it with propane. Pump out the fracking fluid and see what happens. We'll get a little bit of natural gas. And you can see there's fewer contaminants when you use propane. This purple line here is going to be the amount of fracking fluid, and propane is more expensive as a fracking fluid, but it's a little bit cleaner because it doesn't contaminate the water, the aquifer. So with this model, what can you do to prevent the contamination of aquifer by leakage from the water storage tanks? Well, you can not use water. You can use propane, which is more expensive. Propane is a gas under most conditions, so it does not leak into the aquifer in the same way. It doesn't pick up contaminants in the same way that water does. It can dissolve contaminants, but it doesn't dissolve them in the same way water does. I am going to be fairly certain about my claim because I know that propane is a gas, and I know that from just everyday knowledge. I've seen at my local gas station, they have propane tanks out front that you can buy for your gas grill or maybe your camper if you want to run a stove in your camper. I know that some people in rural areas in Minnesota have giant tanks outside their house because they heat their house with propane gas. So I'm pretty certain that propane's a gas from all those real life experiences with propane, and I know that propane gas doesn't dissolve contaminants the same way that water dissolves contaminants. So here's our natural gas. We looked at this in activity 3. We looked at the total natural gas production. And we looked at the shale gas production, and we concluded that shale gas production is probably contributing to the overall increase in natural gas production. Do you think natural gas is an abundant resource that will be around for a long time? Well, I'm not sure how long the Bakken shale deposits are going to hold out. They're making gasoline and natural gas pretty cheap in our local area right now, but it's not going to be that way forever. They're large deposits, but they were formed millions of years ago, and we can't replace them once they're gone. Natural gas is a fossil fuel like anything else. How certain am I my claim? Pretty darn certain. I understand geology, understand how fossil fuels are formed. There are some communities in some places that are making their own natural gas. Biogas stoves are becoming a thing in some rural communities, but there's certainly not enough biogas in these small generation things. There's enough for cooking, a little cooking in a few villages, based on digesting or rotting some animal waste that they collect in the village for these biogas stoves in rural areas in developing countries. And some farms do use their animal waste and digest that to create methane on the farm, but there's a lot of debate around whether we could produce enough methane that way. We'd need a lot of animal waste to provide methane for everyone around the country to heat their homes. It's probably not practical. Worldwide demand for electricity is forecast to nearly double by 2050. A lot of developing countries, people are getting air conditioners, they're getting more devices that you can plug in, more cell phones, more computers, all that stuff increases the demand for electricity. Electric cars also increase the demand for electricity. As you get more gadgets, you're going to use more electricity. So here's the net electricity generation by fuel, and here's the share of net electricity generation world production. Renewables are starting to be more and more of a force, but natural gas is still very important, as well as coal and nuclear. Earth is a system with many electricity generating resources: sunlight, water, wind, fossil fuels, nuclear fuels, and biomass. How would using many different options for generating electricity be more beneficial to Earth than relying on only one type of resource for electricity generation? Well, think about this. If we just use coal, we'd have a lot of air pollution. If we just used renewables, we'd have to depend on the sun shining, and that would not be great in Minnesota if there was a snowstorm. Or we'd have to be dependent on the wind blowing. Natural gas, we're going to run out of eventually. And even burning natural gas in your home produces some fumes. Some people are starting to outlaw gas stoves because of that. And nuclear power has its own problems. There's a lot of waste that we haven't really found a good way to dispose of it. So you can type your own answer for number 19 and number 20. Think about all the different aspects of extracting shale gas to burn to produce electricity, and think about the costs and benefits of extracting that gas. How does it affect local communities? How does it affect air pollution? How does it affect global warming? And when you're all done here, you want to show your answers. And then you want to copy and paste your answers here. It should have your name on it. And then copy and paste the whole document here. And put that either in Notability or a Google Doc or a Word doc along with Activity 3. This is Activity 4. You want to put 5 and 6 in that document. And when you have 3, 4, 5, and 6 all done and all in the same document, hand that in to Lab 5.2. Thanks so much.